Hi, I'm going to show you how to tap a maple tree. The way I do this, I have a couple different types: rock maple or sugar maple and red maple. I mostly predominantly tap sugar maple, which is what we have right here. What we do is take a 7/16 drill bit, drill through the bark and into the heartwood of the tree. And then you put a spile in. And spiles, there are several different types of spiles. These are just a few. And these spiles, this one is made for tubing. As you can see here, it has this piece comes down for drop tubes into a main line. And these are more traditional ones. This is a spile that has a hook and a lid. And this spile is a hookless spile, so the bucket sits on here and it won't slide off because of this piece. So I'll put a hookless spile in the tree and give it a couple taps with a hammer. And you don't want to go in too much because you don't want to split the tree, because what will happen is the wood can get split here and here, and then it dribbles. You can see that from the road sometimes if people have put their spiles in too deep, because it bleeds all over the front of the tree. If it's done correctly, it'll go all into the bucket and not in front of the tree at all. The ideal, this is the smallest of the trees that I would tap. They need to be about 11 inches or greater for one tap, 22 inches or greater for two taps, and over 33 inches for three taps. You never want to put more than 3 taps into a tree. The ideal time to tap is in the late winter, early spring, when you have cold nights and warm days. And last night it was about 10 degrees Fahrenheit, and it's warmed up to about 40 degrees today. So some of the taps that have been out there for a while should be running today. So let's go take a look. This is a tree we tapped 3 days ago. It's over 22 inches, so we put 2 buckets on it with 2 spiles. Yesterday when we checked it, both of these buckets were full to the top, so it was about 4 gallons of sap from one tree. Today, as you can tell, it's really cold, so everything's frozen. It's just barely running, you can see. So there's really no reason to collect today, unfortunately. But of the 63 taps we have out in the sugar bush, we get about between 25 and 40 gallons on a good day. And that's equal to about a gallon of syrup. Okay, this is the reverse osmosis machine. And what this does is it takes sap at about 2% sugar. It runs it through this pre-filter, which is the blue one. And it goes through the first membrane, through the second membrane, and then it splits it up into sugar and a sugar solution and water. So as you can see in this bucket, what's coming out is pure water. And what's coming into this bucket is sugar, or a sugar solution. And you can tell that it has sugar in it by looking at the hydrometer. Now, a hydrometer is a tool that measures the amount of sugar in a solution. And if you look at this one, it's just about at 7%. And at 7%, it only takes about 11 gallons of sugar solution to make a gallon of syrup. This is my evaporator. It's going really well right now. You can see it boiling the sap. And at this rate, I can remove about 5 gallons of water per hour. That means if I have 40 gallons of sap, I can boil it down to syrup in about 8 hours. If you look over here, what I do is I take that solution that I showed you from the reverse osmosis machine, it's at about 7% right now, and I put it in my coffee can. The bottom of this coffee can is a small hole, and it just drips out. And I'm removing the moisture at about the same rate as it comes out of that at that trickle. It smells great. takes a lot of wood to evaporate all that water. And what I put in here is spruce and hemlock, mostly spruce that I have right on the property. And it's stuff that's already dead. It's been blown down, it's lived its life, and it dies. And it's real dry when I cut it. So I'm not wasting anything. I'm not burning fossil fuels or anything. And this is just, like I said, it's wood, and I'll show you where I get it in a little bit. But the fire's real hot, and it's got to go for a lot of hours. This is an example of something I'd use for my evaporator for fuel. This is a spruce tree, and obviously it got blown down over the course of the winter. Probably was diseased with spruce budworm or something. It's really dry inside. You can hear that, crinkle, crinkle. And it burns really well in my evaporator. And I can feel good about this because, like I said, it's not using fossil fuels, and it's very carbon neutral because I can see the carbon when I'm done, and I just use it as fertilizer in my garden. Next thing we'll talk about is syrup density. And the density is how we know maple syrup is ready. And I'll show you in the middle here, I have some syrup that's the right density. And it came off the evaporator, but it hasn't been filtered. So if you can, I don't know if you can see this or not, but there are little flecks in there. And at the bottom, very bottom, you can see where the niter is built up. And niter are just the minerals and the deposits that are naturally found in the tree. But still, we don't want them in our finished syrup. So we filter to get rid of them. But the density is right. If you look at the sides, you can see how it sort of runs down. And it's the right thickness. I'm going to show you two examples. So this is an example of syrup that's a little too thin. Okay? And this is just not quite thick enough syrup. Now this syrup, on the other hand, is syrup that's too thick. So I don't know if we can see it run down the side, but you can also see that there are sugar crystals forming inside the bottle. That's how we know that it's too thick, and we don't want sugar crystals to form in the bottle. We want it to pour out naturally and not get clogged, or not to have the sugar crystals form inside of our jug. So what we will use to get the right thickness, the right density, is a hydrometer. I know it's not the same hydrometer that you use for the sap that I showed you in an earlier video, but it's a different one. And I'll show you when I draw off the big pan outside how that's used and how we get just the right density or thickness in our syrup. Okay, what I'm going to do now is use my maple syrup hydrometer to test the density of the sugar, because we're really close. And I don't think it's going to be quite ready yet, but I just want you to see this before it's dark and I lose my light. So what this is going to measure are called Brix, and I'll explain those later. And if you can look here, it's a hot test of 211 degrees. So right now this syrup is probably about 218 degrees Fahrenheit. I'm going to pour it in here. It's going to cool off immediately, obviously, to about 211 degrees. And this thing's going to bounce up and down. When I'm at 60 Brix, between 60 and 65 Brix, then I've got maple syrup. It's time to stop the fire, and it's time to get this stuff inside. Okay, so give me just a second to get my gloves on, and I'm going to show you how this is done. So just pop open this ball valve, and the syrup is going to go in here like this. Like I said, it's 218 degrees Fahrenheit, and it's going to cool off. And right now we're close, but it's not quite right. I'm going to keep testing this until it's ready at, like I said, 60 to 65 bricks. So this is the syrup that we spent all day outside boiling. This is where I finish the syrup inside in the kitchen under hygienic conditions. So once this is up to a boil, and it almost is, I'm going to filter it. And so here's the filter. It's called a cone filter. It goes, there's two pieces to it. There's this pre-filter, is what this is called. This is disposable. I use one for each time I make syrup. And then there's the permanent cone filter. So that what will happen is the boiling syrup will pass down through this filter, or both filters, into this filling station or filling pot that I have, okay, which I boiled first and then ran boiling water through the spout, and that's where I'll bottle. And when it goes into the bottle, it'll go in at 200, between 180 and 200 degrees, to make sure that everything stays hot packed and sanitary like it's supposed to. I won't actually be able to show that portion of this because I have to work really fast to make sure I get everything in the bottle, and it's kind of dangerous because we're dealing with syrup that's 200 degrees. Okay, here it is, finished product. Took us, we started boiling at about 10 o'clock today. It's 8 o'clock tonight. Everything's bottled up, hot packed, ready to roll. Each of these is a quart. There's 4 quarts in a gallon, so we have 2 gallons. These are a little over a cup a piece, and then I have a pint jar in the back and a quart jar in the front. The the ball jars I used because by the time I got down to these, that I'd lost the temperature, and was concerned about hot packing stuff. So this is stuff that I'll put in the refrigerator and either put in the pot to boil next time and pack it, or we'll just keep it in the refrigerator and my family can eat it. It's fine that way, as long as it stays refrigerated. This stuff that's been hot packed in these containers and these containers, these are tamper-proof caps, and they're sealed, and they'll stay on the shelf forever. I don't think there's an expiration date.